What's going on, guys? My name is Tyler Potts and I am coming to you from the future to tell you that this was a live stream. It was really fun, it went really well, but there's a lot of obviously mistakes that are made. We get stuck a few times, but the chat helps out. We get through it in the end and it's a really fun challenge overall. I'm not gonna lie, I only expected this to take like half an hour to an hour. It ended up taking almost 2 hours. Actually, I think it's over 2 hours long. Yeah, apologies for that, but it was definitely a fun challenge. If you want to stick along and see all the mistakes we make and all the fun things we choose to do, then you can. So yeah, guys, I'm gonna let you go back to the past and watch this video. I think that makes sense. All right, guys, I will see you in the video. So cool. All right, I think it's time to start. So we have the coding challenge number 1. Thanks, Christian. That would be a good start. See, this is why I live stream this, because imagine if I record that whole thing. You are not sharing your screen yet if you haven't noticed. Thank you, guys. Thank you. See, this is why I do it. So let's just say I've created an index.html. It literally is just this. We have our doc type, our HTML, our head with some metadata in, and the title. I then have the body, the script, and I've added this in here. And then there's nothing in our main.js, but we have created it, yeah? So that's what we've got so far. What do you mean no framework? Nope, we're doing raw vanilla JavaScript. I promise you, we're going to build our own Minesweeper class. You'll be able to instantiate your own Minesweeper games into anything. So you'll be able to reuse this. So we could create a new file for this, but then we'd probably be just taking it out of it. You know, let's do it. Let's create a minesweeper.js. And what we want to do is actually get our script loading. We're going to load our Minesweeper game. So we're going to have a class called Minesweeper. And then in here, we're going to write most of our stuff. I came here for Vue mastery. Hey, I do Vue normally, but I feel like these challenges need some vanilla stuff. I never do vanilla, so we're gonna hit up vanilla. And then in here, we're going to have a const we're going to call it a sweeper equal to a new Minesweeper class. So this is what we're doing here. So I've just instantiated I've added in a Minesweeper class, and in our main file, we're just going to call it to get it to load. We also want to we're going to want to pass some things in this. So we want to get reference to our DOM element. And we're just going to say documents.querySelector, and we're going to say hashtag app. And then what we're going to do is we're going to have that as one of the features we pass through here is DOM. So we're going to create a constructor, and what we can do in this constructor is get everything set up. This is what gets called first when you call new class. And in here we're going to say DOM element. We're going to have the width of the canvas, the height of the canvas. And should we say the amount of mines? Yeah, look, you know what? For this, we're turning off Copilot. Disable globally. We do not want Copilot to help us out. It's a challenge. I'm not supposed to be using Copilot, so we are getting rid of Copilot. He's not allowed to help us. And we're going to say mines, right? So we're going to get our mines, our DOM. So we're going to say this dot DOM is equal to DOM. This dot width is equal to width. We're just going to set all the variables to this dot to make it a part of the actual Minesweeper, the instance. So we get the height equal to height, and then this dot mines is equal to mines. You know what? This is going to be mine count. I'm going to change this to mine count, and we'll change this also to say mine count to make it fit what we're doing here. Because this is going to be how many mines we're going to have. So this can't be like the level difficulty. So you can say like 3 mines, 10 mines, 50 mines, however many mines you want, which obviously will make it harder the more mines you add to the game. So this DOM, this dot width, this dot height, and this dot mine count. Cool. So we've got all of those. What else do we need? There's going to be more stuff we need. So how does Minesweeper work? You have a grid. So we're going to need some sort of grid. So let's call this dot mine field and set it equal to, we can leave it at null for now. We're going to create something that creates everything. So we're going to get it set up. we'll call like a setup function, which will create our mine field. So this dot mine field, so that's going to be, we're going to do this in a 2D array. So what a 2D array is, we're going to have one, this will be our, we're going to have one array with multiple arrays in it. Like this, for example. Each one of these zeros will be a section on the grid. It won't be zeros, it'll be something else. And then this is going to be like this. Right, and this is going to be our X. So we're going to have X, 1, 2, 3, 4, and our Y will be this row here. So how we would call this, let's say this was const grid. We would say grid, we want to get the X position and then the Y position. And how this works is this would actually be our X. So this would be X. So it would actually be this way. It looks weird. So this would be, we'll turn it that way to make more sense. You've never heard of JavaScript, Beamy. That's fine, man. This is JavaScript. It's a magical thing. It can do many things. Yeah, so we're going to create some sort of grid with this. And we should probably start off by creating the grid, but for now this is fine. Oh, and now let's create, we need two more things as well. So after that, I'm going to have this dot canvas. And this is going to be equal to document.create. You know, we'll set it to null. We're going to actually create this and this dot context in a setup function. We're not going to have any of these set straight away. So we've got a canvas, a context, the width, the height, the mine count, the mine fields. All right, let's create a setup function. So we're going to create a setup function. This is where we're going to do all of our steps. So we're going to get our canvas first. So we say canvas is equal to create document dot create element, and we're going to create a canvas. And then we're going to say this dot ctx is equal to this dot canvas dot get context, and then we're going to pass in 2D. So we get a 2D context, and then we're going to also say this dot dom dot append child this dot canvas, and that is going to basically get our thing. And when here we'll just say this dot set. We'll call the function. So what we should see here is a canvas straight away. So in here we need to say this dot canvas dot width is equal to this dot width. And this dot canvas dot height is equal to this dot height. So let's break this down a little here. So this is where we set our canvas. So we create a canvas, we create its width, and we add a height to it. We're then going to get the context of the grid, and then we'll be able to append the child this dot canvas to the actual DOM element, which we've passed through in our main. We're going to pass through a DOM. We're going to need a width. So let's just start off something simple, 400 by 400. And then how many mines? If it's 400 by 400, how wide do we want the grid? So how big do we want the actual cells to be? We could say 20 pixels. That would give us, how many grid size is that? So if it's 20, that would give us what, 20 by 20 grid? Maybe that's something we should pass through. Let's say we want 10 mines in a 20 by 20 grid. So let's just say cell size, and we can actually go in here and say this dot cell size is equal to, actually we can calculate cell size by the width and the height divided by, well, no, what we need is this dot cell size, right? So we're going to say this dot cell, oh, not this dot, that'll just be cell size. And then we can pass for our cell size. Now for our mine field, we're going to need to know how many rows we want, well, how many columns, we'll set it to 0 by default, and this dot rows as well. So we want to know how many of those we are. Now to do that, inside of our context here, what we can do is we can calculate, or sorry, inside of our setup, we're going to calculate how we can actually build this. So what I want to say is this dot cols is equal to, and what we can do is we can get the width. So if we say width, or this dot width divided by cell size, and then this dot rows is equal to this dot height divided by this dot cell size. Now this should give us the exact amount of columns and rows we need. define it by our cell size. So in here, we're going to have our cell size as 20. So each cell is going to be 20. Oh, I just closed that. So we're going to have a DOM element. We'll pass in our DOM element. We're getting the width and the height. And we're going to make this square, because if we don't make this square, it may look a bit uneven. And if you want to keep your cell square, you may have to do a bit of, you may have to change stuff a little bit. But we're going to stick to a traditional square style version. And we're going to get that mine count. We're going to set 10 mines in our cell. So this, our columns and our rows should obviously fill out our whole container here. So let's just, in here, let's just console.log this.cols and log this.rows, right? So I just want to know if this is working. We'll see if this is working. We can also log, well, we can actually see our canvas being added to DOM as well to make sure this works. Now I'm going to run this using Livesurfer. You can use, if you guys are, doing your own, you don't have to use Livesurfer. You can just open up the file. I prefer Livesurfer. It's just easier for me to run an NPX. And open this up in Livesurfer. There we go. Let's bring this over so you can see here, F12. We got 20 and 20. That's perfect. So we have 400 by 400. 400 divided by 20 is 20. So we should be good there. So we get that, and let's have a look for our element that's in here. And there you go. You can see our canvas. What's it? Oh, that's the whole app. Our canvas has been added in here with a width and a height all set. So there you go. You can see that's where our canvas is going to be. We could probably zoom this in a couple as well. Oh, not you. This. Because I want to see it a bit bigger when we actually play the game. That'll be fine. There you go. Nice. So back to our console. Let's go back to our code. We can close that. We can even close the sidebar now. All right, so we've got our canvas and we've added the column. We now know how many columns we want and how many rows we want. We now need to set up our actual field, our mine field. So we're going to need this dot setup grid. We're going to create a new function for this, or maybe create grid mine field. We're going to name it to match this. So we're going to create the mine field. So create mine field, we'll create a new function, and in here, what do we want to do? We want to get our mine field. So as I said, this is going to be done in axis and Y. So we're going to do X, which is going to be our columns, and our rows are going to be the axis. So how do we do this? We need to loop through. So let's create well, we actually have a this dot. So we can say for. So if we say for let X, what do we want to start with? Do we want to start with our rows, or do we want to start with our columns? We want to define a cell first. So before we start this, let's define a cell. We're going to create a class, and this is just going to hold information. We'll call this a cell. Now inside of our cell, we want a constructor. And we're going to want, we want to know a few things. We want to know its X and Y position. That's straight away. We want to know its size. We'll just call it size because we know its cell size is in the cell. So we're going to need to know its X, its Y, its size. And we can set a few things. We're going to say this dot X is equal to X. This dot Y is equal to Y. And this dot size is equal to size. We don't want to know if this has been refilled, so we'll say is refilled is equal to false, because obviously it's not refilled when you first click it. That means we've actually clicked it to see it. And we're going to say this dot is mine is equal to false as well. We're going to create a different function to set random mines later on. So we've got an X, a Y position, a size, it's refilled, and it's mine. I think that's all we need for now. Shouldn't be anything else we need to add in here. So let's go down, and now for our X, right? So we're going to say let X equals 0. And then we'll say X is less than, and for the X's, obviously, it's going to be the column. So this dot cols. We're going to want to create our Y's first, aren't we? Because we want to create our rows first. So what we're going to do is say Y, rows, and then say Y++. And that way, now what we're going to do, so if our Y is equal to 0 and our Y's is less than this dot rows, we'll say we want to go this dot minefield is equal to a new array. And then we want to go this, no, we then want to do another for loop, let x equals 0 and x is less than this dot columns x plus plus. And then in here, we want to say this dot minefield is equal to, or this dot minefield dot y is equal to a new array. And then we say this dot minefield y and x is equal to, and we're going to set this equal to a new cell with the x and y position. And then we're also going to pass this dot cell size. And I think that should be good. And then at the end of this, let's just log this dot minefield. Hopefully this works. Again, I'm going on the fly here. I haven't done this yet. I haven't made anything before. So now we have, no, that's wrong, because there we only have a one-dimensional array. So what have I done here? I don't think we need to do this. Another thing we could do is we could set this to the axis. 0, 1, 2, 3. So all you have to think about the x and y is the x position on the grid and the y position on the grid. That's all this index is going to be for. But what do we need? What have we done wrong here? I think it's this. I don't think we need this. No, that should actually be fine. We just have to look at the output again. So we got an array which is empty times 19 and then 20. Let's remove this. Let's see what this does. Yeah, I thought that was going to throw an error because that's currently that is not actually set to anything. So we set the minefield equal to y. This dot minefield y is equal to an array, and then we want to pass x and set that equal to, no, because the x position, does it need to be an array? We want an array into our array, so we create one array which is going to be our y position, and then our x position will go along. So it doesn't need that. I don't think it needs this, because that would be a 3-dimensional array. We just want a 2D array. There we go. So you can see here, this is 0, 0. There's our 0, 0 position. It's got a size of 20. There we go. So that's the array. So this is our grid right here. Hey, what's up, Rado Leitler? I apologize if I butchered your name. Welcome to the stream. We're just getting started for our grid system for our minefield here. And now we have, so basically this is our grid setup. Now we need to generate random, we need to add in random mines, sorry. So we're going to say this dot place mines. Now let's create a place mine function. So we'll say place mines. And inside of here, what we want to do is we want to get we have our mine count, how many mines we want. And we want to basically just loop through. So we can say while we want to check while our mine count. Oh, so we want to say let mines left is equal to this dot mine count. We want to say while mine's left is greater than 0. We're going to want to say, we basically want to go through, we want to say, get a random x, const x is equal to, we get a random x, if we say x is equal to, what would x be equal to? So x will be equal to our this math.random math.floor random times this dot mine count, no, this dot columns, and then const y is equal to math.floor math.random times this dot rows. Is that all inclusive? I think so. So what we're doing here is we're saying get a random number between 1 and 0, times it by the columns. Yeah, that's all inclusive. So that will get us every position we need. And that way we can now, let's just say this dot minefield. We want to check something. We want to say if this dot minefield, and we want to pass our y and our x in, we want to say is mine, then we just want to return. Otherwise, random +1. I don't think we need the +1, but because we're starting at 0. All of our code, our grid starts at 0. So we don't need the +1 here, I don't think. But if I'm wrong, I apologize, and we'll find out in a second. This dot mine y x is mine return. So if it's already a mine, then we're going to return, and that while loop is going to carry on. Otherwise, we're going to say this dot minefield y x dot is mine is equal to true. And then what we want to say is mine's left minus minus, and that should be what we want. And then at the end, let's just log. Well, let's do a quick map here. So we'll say this dot minefield dot filter, and we want to just quickly test if I'll just say m dot is mine, and that should get us an array of just the mines. Let's have a look. We may have created some sort of recursive issue here. It looks like we have. What did we do? Mine's left minus minus. While mine's left is greater than 0, x random, y random, mine field y and x is mine return. So if it's a mine, then return. Otherwise, do this. Yeah, we're definitely broken this. This is like, look, this does not want to work. Right, so we'll say go back to localhost 3000. I think, oh, it's 8080, isn't it? Whoops. 8080. And I think the reason it broke was not because of what we did. It was because I saved early and it refreshed automatically before I added mines minus minus. So it didn't break because of anything left. Although we do have an issue. I'm going to now just quickly say log place mine at, we'll do this in x position y. We can break that down. Place mine at 10, 6, 4, 14. So why is this not coming back? Did I do something wrong? This dot mine dot filter. Dot filter m mine dot is mine. Did I do something wrong in this? This looks right to me. We'll just, this dot mine fill. And then, okay, so we have one at 15, 0. So this first one should be Ismail. No, it's for some reason this last one here. 15, 0. Or have I gone the wrong way? Oh, 15, 19, that is that one there. Cool. So it's actually, oh yeah, it's YX. This is XY, but this is YX because it's the other way around. Let's actually make that clear here. Let's say that Y and that X, because that's how we show it here. So it's 16, 14. So if we go 16 and number 14, we will see it is a mine, right? And it also, look, we've also got zeros and... Oh. No, 19 is correct. No, okay, cool. I was about to say we've also got zeros because we've got some starting at 0 here. So if we go to 12 and we go there, you can see this one's at the start. That means that one works. And we need one at the end, which is a number 19, which is... Let's refresh here. So you can see we've got a 0 and 16 here. So let's go 0 and number 16, and we get a true there. Perfect. So that's at that 0. Now we need a number 19, and this could take a while. But I think it's working because I've seen 19 before in here, and I think that's good. 19, there we go. Perfect. So that means we're all inclusive. It is all inclusive. We don't need the +1. This is perfect. So now we've got our mines randomly placed. Now we need to show this stuff. So what have we done so far? We've got our mine, we've set everything up, we've added a canvas, we've got our context, we've created our rows and our columns, we've created the mine field, we've added mines to our mine. Now, let's start off by displaying it. So let's just say this dot draw. Let's just call it this dot draw, or just draw. Sorry. Let's call it draw. We're gonna have somewhere where we draw. So we're just gonna say for let. How do we do it here? Y. So we start from Y. Y is equal to 0. We can actually just steal this. We want to steal this here for this. We don't need this here. We want this. There we go. Right, so now in here we can say for each item in the grid, we want to say this.ctx.fill. Do we want to make it grey and then when we open it white? Yeah. Fill. And we want to make the fill rect. No, wait. Do we want .fill style, don't we? Fill style, and we're going to set this to just something simple. We're then going to get the actual fill rect. And we're going to set this to the X. So we're going to say X times cell size. So we need to make sure this all times in cell size. Y times this dot cell size, and then we want to pass this dot cell size twice. Okay, cool. We should see some grey on our grid now. Oh, we need to call draw. So once we've got that, our initial thing is this dot draw. Cannot reproduce undefined cell size 77. What have I missed? This dot cell size, this dot cell size. Oh, I put a dot. Come on. There we go. So we have a grey grid. That's actually what we want. We also want a stroke. So we'll say this dot ctx dot stroke style is equal to. Let's do a 333. Nothing harsh in the eyes. This dot. Is it this dot ctx dot stroke? How do you actually call the draw stroke? I think it is just stroke. Is it stroke rec? Maybe? Like this is wrong. Yeah, that creates a grid. That's perfect. Look at that grid. Is that 20 by 20? That's quite big, to be fair. We might want to up our cell size to 40. There we go. That works for now. We'll start for 40 for now. Change fill rect. Change fill rect. What did I do in fill rect wrong? To rect. What, rect? doesn't work, does it? Canvas rect XY number. Does rect work? It has no fill now though. If I fill rect, we get the grey. Oh, so you're saying we do rect and then we just do this.ctx.stroke and then remove this stroke rect. Oh, okay, okay. But now how do we get our background color? Because I wanted that to be grey. Would it just be stroke rect? No, not stroke rect. Would it be... okay, so where were we? We were doing... Cool, so we can stroke it, but then how do we paint the rect? Do we just do this.ctx.fill? Oh, we do! Oh, I like that. That's way nicer. I want to do this from now. Thank you. Boutaleb Hamza. I apologise if I butchered your name. I'm not good with names. Cool, rect, fill, stroke. That's what we want. And that's going to basically just show, well, actually, if we want to do a check, we want to say, actually, we want to get the reference to our current, we're going to say this dot, actually say const cell is equal to this dot minefield, y, x, right? And then we can actually, don't really need to use this dot cell, but what we can do is we can say if cell dot is revealed, then we want to do something else, otherwise. So we want to stroke it regardless, right? So we're going to stroke it regardless. We're going to create the rect, right? So let's do this. We're going to take this, bring this up here, right? So we want to get that set. We're going to create the rect regardless. We don't want to fill it. If it's not revealed, then we're going to want to reveal it. And then we want, and we're, do we want else or return? We're doing else for now. No, because we want them both regardless. So we just return here. Right, so if it's revealed, we don't want to actually... No, because we're going to want to stroke it anyway, don't we? Cool. I got an idea. Put this at the top, that there. And then... So, okay, so now if we reveal it, right, if it is revealed, then we won't fill it because we don't need to fill it if it's revealed. So, refresh, and our stroke's not working. I broke it again. Remove. Oh, because I'm doing the fill. So this. So that does need to be a buff there. All right, that works. Where's our console log? Well, we don't need this, and we don't need this place. Well, I guess we can do place mine so we know where it is for now, and then we can actually click that cell. All right, so we currently have, right? So we have a draw function, right? So now we can actually see everything happening on the screen. If it's revealed, then we won't show it. So let's do a function where we can actually reveal a thing. So in our setup, we'll say this, no, document.add, or no, this.canvas.add event listener, and we're going to say when we click, we're going to get the event. And I know I've messed up there with this, right? So we're going to get the event. Now we have the event. Let's just say we need to get the position and check if it's inside the grid. So we need to say const x position or click x is equal to e.client.x, right? Const click y is equal to e.client.y. And if we log these, click X and log click Y, oh, it's getting the position. Obviously, client Y gets the position of this. We need to get the, is it the canvas offset? So minus this dot canvas dot offset left. If I go right to this corner now, I should get basically 0. Zoom in a lot. Yeah, look at that, 0, 8. So now I need to do the same with the top. Perfect. So minus this dot canvas dot offset top. And now get us the position. So now there's an absolute position to this. There we go. Perfect. So we just wanted to get, so you see the space at the top here. This was obviously counting towards our client X and the client Y. We just need to offset that with the where the position with the position of the actual canvases. There we go. So that works. So now we've got the click X and the click Y position. Now we need to check, well, basically we need to check if that's in between a certain position. So we can say, we can do something called get cell by. Let's create a function. Let's create a function. Get cell by X and Y. X, Y. And now we can say for let X or Y. Oh, I just realized this isn't great. X pass Y pass. Let Y equal 0. Y is less than this dot rows. So we need to do our normal loop. So again, this loop here is going to be used a few times. We should probably create a function to do something that does this for us, or a prototype or something. But regardless, we're here now. So we've got our X and Y's now. We're back in here. We've got our X and our Y. Now we need to check if our, let's get our mine, const cell is equal to this dot mine field Y X. Cool. Now we're going to say if cell I just realized we don't need to do this, because what we need to do is just say this dot mine field dot filter or dot find. Now we can say cell, and we can say if cell dot X is less than xpos, and we're going to do a few of these, so let's break these down. And our cell.y is less than ypos, and our cell.x plus cell.cell or size is greater than xpos, and our cell.y plus cell.size is greater than ypos. That must mean we are inside this. So let me just think about this. So we have square, right? And we've got the x position, so the x up here, and the y position also up here, right? So we get the top corner. Then we get the size. So if we want the x, we add the size, and we've got to check its win there. So we're saying if x is, or is xpos is greater than the original x, and plus its size is less than. Perfect. That's going to work. So we're going to now just say return cell. Return. Now we want to say const or cell or const cell is equal to get cell by x and y, and we can say click x and click y log cell. All right. Undefined. It's all undefined. Why? Is this? Should we do filter? Okay, give us an array. Okay. Let's log this. Well, let's log cell in here when we do this. So click. Okay, so we get 10 cells. And XY plus 40, so that would be plus 40 along here. Do we need the X and Y fields? No, we don't. That's fine, because this is a cell on the grid. I feel like find will work. So dot sum. No, because that gives us true and false if we find it. Can we log the X and the Y? Log X pos, Y pos. So this tells us where we clicked it, right? So that's fine. So what have I done wrong? I've done something wrong here. It'll be something so simple as well. My filters just don't seem to work. Maybe we need to do a for loop then. This dot minefield. Dot find, dot map. No, because that's going to return all of them anyway, right? That's not going to filter them. Yeah, it just gives us a bunch of undefined. Return true, else return false. What do you need to pass in a find? Okay, so returns the value of the first element in the array where predict is true. So actually, all we need to do, this is going to be really messed up, but it's going to... No, we can break this down still. I will break it down still. So, still didn't work. I think array.find needs to return Boolean. Yeah, so this is what this would do. Cell, well, we can bring this back up and we can break that down. So cell, then we do this check and we should return it, but I'm just not getting anything. We're just gonna comment this bit for a second and we're just gonna do our for loop. So for, well, let's go get it. We'll try our for loop. If for some reason our this isn't working, and this is why it's a challenge and not a tutorial, because this is for me to find mistakes as well. And then we can just get const cell is equal to this dot minefield y x. Oh, of course that's not gonna. Yeah, of course this isn't gonna work, because the minefield is a 2D array, not a singular array. So you can't do that. You'd have to flatten the array. We might be able to do this. Hold up, let's just do minefield dot flat. Alright, it's not working. I ain't gonna spend any more time thinking now, and let's get this one working. So now we can get the actual cell, because the problem is we'd have to do .find essentially to get this to work, something like that. Something we would have to, because obviously we've got an array inside of an array. We've got arrays inside of arrays, and that's where obviously we'll get an issue. So now we'll just get the cell the old way. We'll say if cell dot x. Well, we'll do the same thing here. If cell dot. Right, we'll break this down. Why not just divide y pass and x pass by cell side to get the x and the y indexes? Divide y pass and x pass by cell size. You are right, but where I click may not be exact, right? So if I click, because the grid is 20 by 20, if I click, let's say, 312 pixels in and divide that by 20, that's not going to give us, it would have to floor it, and that might, would flooring it work? Flooring might work. You know what, Abhay, I apologize for butchering your name. That might work. Let's try it. Let's try your method. Let's give this a go quick, because that would be neater. So we're just going to return this dot minefield, and it will be minefield. And to get the y position, then we're going to say divide the y pos divided by this dot cell size, and we want to floor it, right? So math dot floor because we're not going to want any integers. And we could do the same thing for the xpos. That gives us 5. So is that 5 in? 1, 2, 3, 4. Oh, 0, 1, 2, 3, 4, 5. Yeah. Let's do just top one. 0, 0. 1, 0. 2, 0. Yo, Abhay, that was great. That was, you have created. So look how easy that is compared. I was going, I'm just not smart. There we go. Now that has fixed us. Thank you, sir, for helping us out with that one. Nice one. That was actually a great idea. I don't know why I didn't think of that. Probably because I'm not as smart as you, but we don't talk about that. This should be 1, 1, 2, 2, 3, 3, 4, 4. Let's just get this N1 9 by 9. Yeah, it's 10 because it's 10 grid now, not 19. Cool. That's fine. That's fine. So now when we click, we get this cell and we just say, cell.isRevealed is equal to true. And what we can do is just say, what we're going to say, we're going to say we're going to say this.draw again to draw the new revealed one. I don't know if that worked. Oh, every time we draw, we also call here. So let's clear the canvas every time. Let's say this.ctx.clearrect 0, 0, this.width, this.height. Still looks like it's doing the same thing. That's fine. All right, so let's come in here for now, and what we want to do is this.cell is revealed. So if it's not revealed, we're not going to do it, which means it would be white, but for some reason, it does not look white. Let's also do, let's do the thing, let's also say, before we fill, no, if cell.isMine, what we want to do is say this.ctx.fillStyle, we'll set to like a red. This.ctx.fill. Let's refresh this. Oh, that was buggy. 0, 2. So 0, 2. Something isn't working. Cell.isRevealed true. We log cell. Oop. So that says it is revealed at 4.3, which should be revealed at 4.3. So 3.1. Okay, so my draw function isn't drawing it correctly, which is fair. I've probably done something wrong here, so let's have a look. So we're getting a fill style, stroke style straight away. We're getting the rect, and we're saying, is it because this shouldn't be done here? No, because it needs to be done first, right? The rect needs to be in place before we fill the rectangle. Maybe if it's revealed, then fill. Wait, if revealed, then we fill it? Well, I know for a fact that you guys are not mine. Definitely not mine, so why are we red? Let's just log. Is mine. Is mine, and then we'll say the cell, and we'll also say is revealed, and we'll pass in revealed. So that just shows us all the mines. That should have been obvious that I was going to do that. And then is revealed is now 9 by 5. And every time we click this, there should be more and more that gets revealed. So all those start ones, yeah, look, more trues are appearing. All right. My draw function just isn't working, obviously. We need to do something about this draw function. So for each So for each cell, what we want, maybe we should do a map. This is fine. So for each cell, get our fill style set to that, a stroke style to that. I don't feel like our clear rect is working either. We clear rect at the end. I just want to test something. Yeah, it's just an empty thing. So it is working. But look, it's white at the start, and then when you click, it goes grey. I have broken something, and I don't know what that is. So this .draw will get called when we click the canvas. It also gets called at the start of the setup, so it's drawn. So what could be wrong? It's going to be something so simple, and I'm going to be so mad at myself when I find out. Let's try this. Let's go back to the old way of doing it. Let's just say this.ctx.fill_style. You know, we're not even going to add a fill style. You know, let's try not adding a fill style until we actually stroke it. So here, let's get this. Oh, do we need to... Do we need to clear like the fill? Yeah, let's change E to something worse. Let's change to like 666. And then when it comes back, I know what's happening, I think. So what we need to do is we need to begin path. There we go. So that's where our mines are. And then this isn't filling. There we go. So now we need to do the opposite. So if it's not refilled, it's filled with an EEE. There you go. Let's make that not EEE. So let's make it something darker. Let's say CCC. Obviously, we don't want our mines to show. If we need to say cell.is refilled and is a mine. Wow, this is the best luck I've ever had on this game. There you go. So you can see we've refilled one. Now we need to get the numbers in there. So we need to do something called counting the neighbors. We want to basically, for each cell, we want to count every single adjacent one to know how many mines are nearby. Okay, we can remove those logs now. Yeah, so basically it was keeping this E fill, this EEE fill when we went round, and obviously that was causing issues even though we were clearing the rect. It was causing issues in the loop. All right, so we've got that, we've got that. So we need to see numbers. All right, so now we need to do something called get. So place mines. Once we've placed the mines, we want another function called count mines. And this is going to count the mines, count neighboring mines. And that with this, we should now, for each cell, we need to check if it's a mine. If it is a mine, then we don't need a number. It can stay at 0. So here, let's come up here. In our this, we need this. This dot neighboring mine count. That's quite long. We'll set it to 0 by default. Neighboring mine count, right? And now in our count neighboring mines, we'll do this after our place mines. So we'll say this, we have to do it after our place mines because we want to, we want to basically check if the ones next, obviously the mines need to be placed before we check for them, obviously. That's what I'm trying to say. My brain's going mush now. How long are we into the stream? It's been days. Cool, so let's crack on. Count neighboring mines. We will say place mines, count neighboring mines. So we want to loop, we need the loop again. We need our famous double for loop. So we've got our double for loop, get 1, 2 in there. Now in here, we're going to say const cell is equal to so for each cell, we want this to be this.mines. You know, this is right here. Where is it? Right here. So now we don't want to get for each one. Do we want to loop through again? Oh, that might not be fun. So if we count them all, so if we loop through them, we get the cell, and we check if the one on its, if +1, 1 is -1, 1 is -y and -1. There's a lot we need to do here to get this to work, unless there's an easier way to do it, which there probably is, but my mind isn't thinking it. We need to say if we say cell count. So for this cell, each one we loop through, we're going to need to loop again, but that doesn't feel like we should loop again. So once we get each cell, we want to check to the left, the right, if we can go left and if we can go right. So we want to say xpos is equal to x -1. So that's going to get our first back, and our const ypos is equal to y -1. So that's going to get the top left one. Then we need to check the top right. So we need that one, stop, carry on. We need to make sure our x position doesn't go beyond our y. Const, say while while I is less than 0. Let's just create a let I equals 0. While I is less than 9. So while I is less than 9, because there's going to be 9, there's 9 grids, we want to say if loop over mine positions, I think better. What do you mean? What do you mean loop over mine positions? While I is less than 9, because then we can, because we know the starting position. That's going to be top left, right? That's going to be the top left cell. We can go across. If there's a better way to do it, then please tell me. My brain is. The thing is, I've seen people do this before, like how they can target cells all around it, and I can't think of how you do that right now. It's been too long. Let's carry on for now, and if you know the better way, then tell me. My brain isn't going to work right now. If x position is greater than, no, it's less than 0, because we can't have it less than 0. Return. If y position is less than 0, return. Oh wait, you know, we can do this in one call. What am I doing? If x position is less than 0 and x position is greater than this.cols, return, and if y position is less than 0, and if y position is greater than this.rows, then that's we can return, because that means we're outside of the grid. If I is not equal to 4 also, so you don't count the revealed one, is that the number in there? So that nice one. So and if y position, no, sorry, if I is not equal to 4. All right, I'm going to trust you on that number because I can't be asked to do maths. 0, 1, 2, 3, 4. You're right. You're right. So you don't count a nice one. So that works. That works. And then all we want to do is we just want to say if this dot mine field. Oh, let's get the mine. So we'll get that cell. Const c is equal to this dot mine field. Y pos x pos. We'll say if c dot is mine, or if it's not a mine, return. Else, if it is a mine, we're going to say cell dot neighboring mine count plus plus, and that should work. I definitely have faith in my ability to do math. And let's just log this dot minefield. I created an infinite loop while we were there, so let's just localhost 8080. This should work this time. Uncaught reading -1. See, that's what I did on 1, and that's what I thought this would stop. Which line is this on? It's saying 136. 100. Yeah, so see, so this is for some reason outside of scope where we didn't want that, because what we said here is if it's not return, is it? We don't want to return, we want to continue. Also, it'd be nice if we actually increase no, because we need to that needs to be less than 10. That would be -1. Is that gonna work? Can we close this one now? There we go. All right, so probably undefined -1. I've got an issue here, and I can't remember. I can't realize what I've done wrong. So if I is less than 9, should be 10 too, shouldn't it? Because if there's 10 rows, or if I is less than, no, 9 is right because we're not doing the rows, we're doing the thing. That's fine. So I -1, because we're adding it here only because if we add it down here, we have continues, and we want to continue without worrying. Maybe it'd be better in a for loop. For let I equals 0, I is less than 9. Then we don't have to worry about incrementing. I plus plus. And that doesn't need -1 anymore. Oh, also that needs to be let, and we need to, so if X position is less than 0, then we don't do it. If X position is greater than this.cols, we don't do it. If Y position is the same and less than, okay, that seems fine. That seems fine. So cell neighboring. We need to increase the Y and the X position once we've checked. So this ordering doesn't really work. You know? Is that what we want? And then what we're doing here is instead we'll say c.x, c.x, c.y, and c.y. No, idiot, that's not going to work, because I just realized the whole reason we're doing this check is to make sure this exists. C is mine, continue, neighboring mine, cell. Mine filled y plus x plus. This not minefield, y pass, x pass. What's the error we're getting now? Undefined -1. So this is going to be -1 because this starts off at -1, so it's not going to even start. But the problem is we need to make sure it's not -1. That's why we're checking if it was the wrong way round. X needs to be greater than 0. No, because we're checking it. If not, we're going to continue. Straight up -1, so this doesn't work. This isn't stopping. Oh. Or continue. There we go. It was because I did this wrong and I needed I need ors, not ands. So now, does our array tell us the cell 1, neighboring mine 0? Where's our mines at? 2, 0. That's y and x, isn't it? So 2, so 0, 1, 2. If that one's in the corner, no, that's fine. So that must mean this one here should say 1. No. Let's display the count so we can actually see it visually. If not written, let's just, for now, let's just pull it in anywhere. At the top here, say this. Actually, it'll need to be at the bottom, right here. How do you do text in this again? This.ctx.text. Text align is equal to center. This.ctx.text baseline is equal to middle. This.ctx dot font should be like it's equal to 20 pixels area, and then this.ctx dot, and it is, I will find it, fill text. Is it fill text? I don't think it's fill text. God, there's so many. Measure text, that's cool. Stroke text. Let's have a look. So we've got fill text. Let's just do fill text. Oh, and this will be at x and y. Oh, and the width and the height. Fill text. It is fill text. Oh, and we need the text string. So this will be this or cell dot neighboring mine count. The x will be this dot, no, cell dot x, cell dot y. Max width doesn't really matter. It looks like they're all up there. We also need to set this dot fill style equal to black. Classic mistake. Yeah, thanks, Callie. Khalil, sorry. Iad Khalil. Tell me off a butcher name, by the way. Seriously, I apologize. Okay, so fill text. This dot fill style. This dot text line middle font. This is just position x. So we want the x plus this dot cell size plus, or times, sorry, times this dot cell size. Oh look, there's zeros everywhere. There's ones. They're off center though, so let's figure this out. I now need to move from center, so this needs to be divided by 2. No. No, this needs to be plus this dot cell size divided by 2. There you go. Alright, I know this is broken because, well, some of them... Why is those ones red? Look, it's set right here, the fill style, so why is that fill... Oh. Oops. There we go, that's good. So it just says this one here. Where is it? There. It's only working for the top left because we are not incrementing our X position and our Y position here. So what I want to do is, for each one, we want to... That's not going to work. I've also just realized this is flawed. For each one, we need to increment only X and only Y. So we need 2 loops here. We need a loop to check the X and a loop to check the Y. So we are going to need to do 0, 1, 2. Because this is only ever going to work if it's at the top corner. So look, I can know exactly where every single one is because this is only checking that top left corner. And we're running this 9 times. That's just not what we wanted to do. So this isn't going to work. We need to do this differently. I need to... Do we do for X position? X is less than... So if we leave these like this, and then we just say I is equal to X pos. No. This is such a simple thing in my head, and I, for some reason, cannot do it. Cell is equal to, so we just need to check around it, right? So we want to -1 and add 1 to each one. So we have this cell's X and this Y, right? So this is X and this is Y. And we just want to go back one. This loop isn't right. Everything else is right, but this loop is not right. So, how do we fix this? I could Google this, but I feel like that's cheating. I feel like we need to fix it ourselves. Or fix it myself, should I say? This dot minefield y x continue. So this would work if our X and our Y would increment during this 9 phase, but we can't really do that in the way this is because we need to increment the Y position only 3 times and the X position only 3 times, ignoring the middle one. 1, 2, 3, 1, 2, 3, but we need to do it increment. So we need to do X first, then 1 Y, then X. So we could do a pseudo element here. So right after this, what we could do is we could say, no, we need to do it straight away. So maybe a double for loop again. We could do a double for loop again, but then, okay, we're going to do a double for loop again. So what we're going to do, now, how do we check? So this is our loop again. So this will be, so we've got this, and then we're going to loop from all again. We need to check if they're only -1 away on either X or the Y. So how do we do that? So we want to say, oh, this can't be X and Y either. We can, this should be, well, this is where we could put our Y pos and our X pos. And we don't need this anymore. All right, so now we've got a double loop. This isn't going to work. We'll probably keep that there just for a moment, because that's not going to increment. This will increment it, and this. So we need to check if the Y pos is within the parameter. So we can say if Y pos is less than, no, if yes, so what I want to do, if Y pos, so as we'll say, if, let's get the cell. Let's just get the cell. Const C is equal to this dot minefield, Y pos, X pos, and then we can say if C is not equal to cell, right? Or if it is equal, we're just going to continue, right? Because we don't want to do anything there. So we don't want to do anything if it's already a part of it. Then we need to check if it's next to it. So if it's the top left or top right. So we need to say if cell.x -1. No, because we can't just do -1 every time. We need to do it so it's automated. If c.x is less than or is greater than cell.x +1. So if it's greater than, it, or c.x is less than cell.x -1, or if it's less than it, or c.y is greater than cell.y +1, or c.y is less than cell.y -1. Continue. Now, I don't know if this is right. So we're saying if it's not within this sort of loop, let's just log C cell. All right, let's go to the top. Let's just see the first one, right? That was a lot. All right, so 1 0 0 0. Obviously, we're ignoring this one if it's doing itself. And then we're going to 0 1. So it's got this one, and it's got this one, and it's got this one, but it does not have any more because that's it. That's done it. Oh, we've done it. Okay, so we need to say cell dot neighboring mine count. Oh wait, we'll say if not c dot is mine return. Oh, continue. So these are our continues. We can put these into one if, but to keep it clean, we're going to leave them as 3 separate ifs, right? And then we just need to get this and say cell plus mine count. And now we go back. Okay, so there's 3 chances of being around here, and this is 0, so it's not that one. It's that one. You can see 3, 3 there. There's 2 here, so one of these should also, no, these are all 1, so these ones will not be. You can see these are safe. 1, it's already gone out, so it's not that one. It's not any, they shouldn't be 1s, but then again, we are looped for it, so we need to check if this cell, so we'll say if cell dot is mine, continue. Down, down. So that's got 3 because that's in between 3. This one's got 2 because it's got 2 in it. This is 1 because it's got 1 in it. This has got 2, so it's got this one and this one. 3, this has got all 3. 2 is, oh, this one. These are all clear. That one is a red. That one is not red. That one's a... It's got to be that one. Idiot. I was looking at these ones. I was like, why is this not? But then it's because this one here. So that's 2, meaning this one is also a red. And this one. That one can't be. Something's broken. I am running a console. Oh no, we want to know where the mines are, but we don't want to know where this is anymore. So this is working, I'm pretty sure now. These numbers are working. But one thing that isn't working is, see here, all these zeros, they're not flood filling. And also we need to go back into our Minesweeper and we need to make sure we can't see the numbers until it is revealed. So what we want to do is we want to grab this. This actually needs to go at the end. Because even if it is a mine, there you go. So there's our 2. So you can see our numbers are hidden under here now. Zeros don't need a number as well. So we want to say if, where's the text? So we'll say if cell.neighboring count mine is greater than 0, then we add the text. Also, we now need a flood fill feature. So here you can see there's a bunch of them. Now on normal Minesweeper, when you click a blank one and there's blank ones next to it, they all open up, including these number 1s on the edges. Now, how do we do that? So we've got a flood. How would you achieve a flood fill? How does our neighboring one work? It's basically the same thing. We want to just check the neighbor. Want to check our neighbor and just basically say if the neighbor doesn't have any mine counts, if less than 0, yeah. If less than 0, so we can just loop through it, check if it's next to 1, which is 0, and then problem is, right, if we don't want to just refill all of them if they're 0, because if we clicked here, this should flood fill, but it shouldn't flood fill anywhere beyond this. So like if there's blank ones down here, only if it's, see, this shouldn't refill that. Okay, it should. Should it only flood fill up and down? It should only flood fill to the top and the right. It shouldn't flood fill the corners either, I'm pretty sure. So here, if you clicked on one of these white spaces here, it would flood fill all of this except these 2 up here because they're not there. So these ones would be ignored. It would also reveal, see these ones? It would also reveal all of these. So far we have completely flood filled the whole thing, right? We haven't. We've completely opened the whole thing. We can see which ones we need to flood fill by just clicking. If we clicked on this one, it should flood fill left, 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 right, 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 down, 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 all around here. Now, how can we do? There's got to be some sort of flood fill algorithm. I bet there is, but I don't want to Google it. All right, so let's figure this out. On click, so when we click and we get this cell, it's revealed is true. If cell dot neighboring mine count is equal to 0, then we need to run a function. So down, let's remove these console logs from a lot of these places. Cool, yeah, so up here, if our neighboring mine count is equal to 0, so if it's dead equal to 0, then we want to check the one to its left, to its right, up, and it's down, and we want to repeat that. So we want to put this in a function, right? You know what? We can put this in. Check. Let's call it flood fill. We're literally going to create a function called flood fill, right? Say flood fill. This is actually going to take a cell, the current cell. So we're going to pass through our cell in here. I'm going to say, if the cell neighboring count is 0, we then want to check the ones next to it. So we want to just say, would it be flood fill +1 flood cell +0? Okay, I think I have an idea. This may or may not work. So we want to say, there's 4 possibilities we can flood fill with this method. So we want to say, if cell.neighboring mine count is that, is 0, we want to check if const neighboring const c is equal to mine, no, this dot minefield cell.x -1 and cell.y. Right, so we want to check the left one. Oh, I actually need to do this. Cell.1. We can say if c, we'll call it c1. C1. Then we also need to check if it's in the bounds again, though. We'll say if it's not refilled. So if it's not refilled, then we want to try and it is 0. So we'll say if not refilled and c1 dot neighboring mine count is equal to 0. Then what we want to do is say flood fill. No, just flood fill. Oh no, it's this dot flood fill. Ignore me. This would also need to be this dot flood fill. This dot flood fill, and then we're passing c1, and that's going to do all of the ones to the left of its side, right? So that should work. So that should go back and forth on the left and just go all the way back left. However, we also need to check if the right, up, and down, and it will just basically span out like from the center outwards. We could do else. No, if you want to do this multiple times, I'm going to do a really rough version right now. So we're going to change this to 2, cell 2, cell 2, cell 2, and we're just going to +2. Also, we actually have to refill it as well. So if it's not refilled and it's neighboring frameworks, we'll say c1.isRefilled is equal to true. And we're going to do the same down here. So we'll say c2.isRefilled. Oh. And we're going to pass it on. And that's going to +x. That's going to go to the right. So, well, you know, let's make this even better. Let's just target all these. Left cell, so LC. Then I'm going to do this. D. Right cell, I've missed one. Then we're going to get both of these. Actually, no, we're just going to get one. Change this D to be top cell. And this is going to be -1. And this one's just going to be cell X. Then we're just going to go bottom cell. This might be a really crude way of doing this, and there's a much better way to do this than what I'm doing right now. But we're just going to try. And now this should flood fill all the blanks. He hopes. IsRefilled, 63 IsRefilled. So if okay, so I think this is the issue I was thinking about earlier, where this has gone off cell now. So we want to check if if this is within, so we'll say, before we even check this, we'll say if cell.y will be if cell.x minus 1 is greater than 0, then we're going to carry on. There's minus, it's going left. Then we want to say if cell.x plus 1 is less than this dot cols, we want to do this one. Then we're going to say if this dot, no, we're going to say if cell.y minus 1 is greater than 0. Well, it should be greater than or equal to, right? Greater than or equal to. I don't think that one needs to be equal to, that's just less than. Greater than, and then this one is if cell.y plus 1 is greater than, no, less than this dot rows, we can do this last one. Oh, this needs to be plus y too. I've just noticed it was minus y. There you go, flood fill kind of. You kind of always need to reveal the next one though. So all of these actually need to be revealed straight away. I have an idea, this should work, hopefully. Straight up got here red. That's fine. Okay, didn't work. Actually broke it. Alright, so let's undo that. There you go. So you see that's gone straight in for flood. If I click this, these are probably all safe, right? And that's the issue with this type of flood fill, is it should have basically done this the whole way round. It should have went round the edge and cleared all of these ones as well. And probably even that. That was obviously going to be one. I don't know why I clicked it. Yeah, so it should have went all the way around and basically marked them off. But the reason it didn't is because our thing stops before it can. It checks if it's revealed. No, it checks if its neighboring mine count is equal to 0, then reveals it. We shouldn't. The thing is, adding it there should reveal it. Oh, but then we check if it is revealed. So we bring this to the bottom. Oh, okay. Now we have an infinite loop. Oh, because it calls flood fill before this now. Okay. Another method. So we need to check if the current one is equal to 0. So if this cell is equal to 0, that's fine. Then we're going to check the ones around it. Right, if that's equal to 0, then it's going to, everyone around it is fine. So what we want to do is we want to move this. I think this neighboring mine count needs to be below this. There needs to be a second if. The only way this is going to work is if we have a second if. I think this is how it's got to work. And let's try this with everyone. So I'm going to have to change this from. We could just. Can we copy and paste this? We can't copy and paste this, can we? Copy and paste the insides, right? No, from here. Okay, and this one, this is going to be DDD BC, and then from here, that's it. Why have we got such bad luck? Okay, see, that's flood. Still didn't work. It worked, but it didn't work. Because it's supposed to do this. It's supposed to go all the way around here, and it was supposed to reveal all of these, yeah? It didn't. Why didn't it? Because it hates me. This is a red. Definitely a red. Boop. Okay, so it's kind of working, but it's not. We're almost there. We're literally got so much little to do. Once we've done this flood fill right, all we need to do is say when we click on a red, game over, you lose. If you don't click on a red and you get all the way to the end, and you manage to refill all of them except the reds, then you win. And that's all you need to really do for this. I'm not going to add a timer to this. I don't think that's necessary for this. We'll just have to, if you get to end, you win. If you don't, you lose, regardless. You can add timer to it yourself if you want. So why is this not working? So this. So if it's revealed, oh, that's still in the neighboring count. This one, it doesn't matter. There you go. We did it. We got the flood fill working. Let's just randomly click in it. Oh, ooh, dangerous. 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 Oh, God. Okay, so now, once we click on a red, we need to reveal everything. So we've just got to go through everything, reveal them all, and say game over, yeah? So now we're going to create a function called game over. Game over. And this is easy, just a for loop like this. And just say cell.is revealed is equal to true for everything. For now, we're just going to alert a game over. And we'll just say this.draw before we do that. Okay, that did not. Oh, because we're not checking for game over. We're not actually calling game over. So if when we click, so in our click method here, in our canvas, this dot reveal cell is equal to true. So cell, all we need to do is say if this dot cell, or no, if cell dot is mine, return game over. This dot game over. Game over, and there you go. We lose, and it shows us where they all were. Cool, and there you go. Now that's game over. We can refresh to restart. Wow, this is a really easy one. Is that 1, 2, 3, 4, 5, 6, 7? Why didn't all... Okay, so here's another bug. All the mines didn't get placed. And why is that? So when we place our mines, how many mines do we set in our main? 10 mines. We need at least 10 mines. And what is that? 1 second, I'm just going to check the audio playback myself just to see what it's doing. 10 mines. We need at least 10 mines. And let's just see. What is that? 1 second, I'm just going to check the audio playback myself. It seems fine for me, Carlton. Obviously, it is my stream, but I'm checking the YouTube playback and it seems fine. You probably heard that actually. Check the audio playback myself. It seems fine for me, Carlton. Obviously, it is my stream, but I'm checking the YouTube playback and it seems fine. You probably... For audio, is good. Okay, Carlton, I apologise for you having issues. It may be on your side, not mine. I think it is all right. I apologise if there is any issues and it is my fault. I don't think it is in this instance. Okay, so we called place mine. So let's go find our place mines function. Mines left is this dot mine count. While mines left is greater than 0. So that only play... One, two, three, 4, 5, 6. It only plays 6. Why? Mines left. It was this dot mine count. One, 2, 3, 4, 5, 6, 7. Return. Continue. that should place 10 mines every time. I was returning completely out of function, so as soon as it hit enough of mine, it broke. I've got to remember, continue, not return. Return will cancel out of it. Minefield minus mines count. Is there a win state? We're literally about to create the win state in a second, Carlton, so you can get the exact number. But let's test if our lose state works. So okay, that's 1. All right, there you go. The flood fill worked amazingly. 1, 1, 2, 2. That's 1. That one's definitely 1. That means that 2. That 2 can only be either one of these 2. Which means these ones clean. And there you go. Flood fill work that side. Perfect. 1, 1, 1. That's definitely 1. So that one's clear. Which means this one's clear. Which means 2. So that one is and that one is. 2 is going to get one of these. But that's a 1, so that one isn't 1. Cool, so that's 3. So that's got that one, and that one. I mean, this one is clear. And there's 3 again, so that's good. And that's a 1. That's a 1, which means it's either it's one of these 2. That's a 1. That's a 1. That's a 1. That's a 3. And that's got those 3. So that one's clear. And that's a 2. So it's out of these 2. That's a 1. That's 2. That's 3. That's 3 and 2. 3. These 3 are definitely it. Right, and that's a 2. That's a 1. That's reaching there. That one is 1. This one's clear. It was not clear. I selected the wrong one. Damn. But there you go. You can see how that works. So you can lose. So you can get the exact number. So now, yeah, we need minefield's length minus the mines count. And that will give us our remaining fields we can click before winning. So what we want to do is up here, we should create another one. This dot remaining cells, and we're just going to set this equal to null, and then in our canvas we're going to set this up here after, because we have to do it after we place our mines. We can even do it after this. What we're going to say is this dot cells, remaining cells, is equal to this dot minefield dot length minus this dot. You could also, I think, no, you can't. Oh no, because that's not going to work. Because this is an X and Y. Again, this is another loop. This might need to be another loop system. Because we've got, again, it's just, what does flat do again? Dot flat map. Returns a new array with all sub-array elements concatenated recursively up to the specific depth. Word function on each element on the array. Flat dot length minus this dot mine count, and then let's log this dot remaining cells to make sure it looks right. 90. That's 100. That's 10. Yeah, that's perfect. It should be 90 every time. It is perfect. So it's 100 cells here, 10 by 10. And let's just make this, let's just say we want 15 mines, so we should get 85. Perfect. 10. No, let's do it 15. Cool, look at that. So if that's 1, that's not 1, so that one's not 1. That's 1, that one's 1, so that's it. Now we just need to, all we need to do is say on click. So in our click, we just want to say cell ifs mine if cell. We'll say this is what I'm saying, minus if remaining cells is less than 0 or is equal to 0, alert, you win. Let's just see how that works. So, you know, let's also make this easier. We'll do 1 mine. Found it. Game over. Yeah, so obviously that's not going to work because obviously, well, no, because when I click, that doesn't need to minus because the flood fill won't actually work. So we need to do a different function here. Actually, I think I have an idea. All we need to do is say, we just need to do this on the fly. We're just going to say check for win. We'll create a check for win function and this dot check for win. This dot check for win. We'll do it right here. Check for win. I've noticed I've named this find. There we go. Check for win, and all we're going to do is say for each one. So we're going to do this. I think this will work. We'll flatten it because we don't need it in our we don't need to know about it in our 2D array. So we're going to say const field check for win, and we'll say it's a field. Cool. So all we need to say fields or cells. That makes sense. Cool. So we have our cells. Now what we want to do with our cells is we want to take our cells, we want to minus the flat, the minefield, the flat. So we've got our field, so we've got our cells, right? And we need to check if they're all refilled. So we need to get the number of ones that are either, so we'll say for each set, or for cell in cells, right? So if we get our remaining cells, we can actually say cells.length minus this.mineCount. If cell minus mineCount. Wait, you know what? Remaining cells. Hold up. All we need to say is dot filter cell. Remove this. And then we need to say if cell.isMine and cell.isRefilled. Which one do we want to return? We want to return if cell is not mine and it's refilled. Log this dot remaining cells. Right. So now we click. The remaining cell is a mine, so we need to say if cells so we need to say if this dot remaining cells dot length is less than zero. See, that's still a remaining cell. So if its cell is not a mine and cell is refilled, should be all. So these are all the refilled. No, that's all the cells. Khalil said, or just equal 0. So true, I could just say 0. You win. I have to get this down to 0 though, and if I go back here and do this an and again. It says it's 98. Is that because the flood fill runs after? Yep, we need to run the flood fill. The flood fill first. You win. There you go. So, yeah, the reason it wasn't giving us it was because flood fill hadn't happened yet, and there you go. So you win. Obviously, we want to say if. We also want to say if cell.isRevealed return, because you don't want to click on one you've already clicked on. See, now we can't click on it again. So now let's go back to main. Let's just make this 4. That'll do. Right, now, if I click on nothing, it won't do it again. If I click there, game over, we lose. All right, so that's a win and a lose state, essentially. So you could do better. Obviously, I'm doing alerts for the win state right now. So when you come here, we can say, okay, so there is 1 cell left, literally. So that's that. That one's not it. Bam, you win. And that gets ourselves down. So let's remove the console log. And there you go. So if we now put this up to, let's say something a bit harder, 10, we can go there. Okay, cool. So this one's cool. That one's definitely 1. So these ones are cool. This one is 1. It's 2, so I've got to be careful that way. That's 2, so I also have to be careful. That's a 2. That's a 2. Could be any of those. 1, so that one's definitely 1. 1, which is definitely this one. That one's clear. 2, 1. So it could be that one. 3. It's a hard one there. 2, because that's definitely 1. 1, that's definitely 1. So these ones are all clear. Oh, I said those ones are all clear, but I didn't think of the gap between that one. Sucks to be me, but there you go. You can see how it works. You can lose, you can win. And I think that's it done, guys. Have you guys got any questions? Let's sit down. We have been grinding this for a solid 2 hours. So, hi, welcome down here to the chair level. All right. Yeah, guys, I think that's good. There's 2 features that are missing from this. A timer. Actually, 3 features. There's a timer missing. You should be able to flag. So with a right click, I should be able to add a flag to this. So we should draw a flag. I could put a red dot on it for now if we wanted to. But I'm not sure I'm going to do that now. And another one we could do is we could also, so I said timer, flag, and we can also add proper win and lose states and a restart, like a menu sort of thing to be able to restart and retry. So there's some things missing from this, but you can create multiple of these. So with this sweeper, we can create const mine, just for contrast, and we give it a DOM. We can say this one, we only want it to be 200 by 200. We want the cell size to be 5, and we want there to be 5 mines and the cell size to be 20. And there you go, you've got a smaller version of it all here. Obviously the text, you might want to scale the text down when you get smaller. So yeah, you could do that, but look, 1 here, man, that's fine. That one's definitely 1, 1, 1, 2, game over. Boom, and you lose that one, but you can still play your second one. So you can see here how you can add multiple of these instances now just by calling this Minesweeper class. And that's all done in this. So you don't need any of this or any of this. You just need this Minesweeper JavaScript. Add it to any website you want, and you can do the same by just going into your file and adding in all these elements here. These are the only bits you need to re-add to get this to work now. And there you go. That's it. You've got your own Minesweeper class, your own Minesweeper like mini game you can play anywhere on any website. And that's it, yeah. And there was a bunch of other people who helped me out the whole way through, so thank you all for joining. That was a lot of fun. Definitely do more challenges if that's what you want to see. But for now, guys, I'm going to end the stream here. Thank you all for tuning in, and I will see you in the next one. Peace out.